Parametric functions continue. X and y are functions of t. T is a parameter. Then the derivative of y with respect to x equals the derivative of y with respect to t over the derivative of x with respect to t. Think of this algebraically, putting this fraction over this fraction, dividing the dt's would cancel, so this would of course equal dy dx. And the second derivative of y with respect to x is going to be the derivative of the answer we get up there, dy dx. The derivative of that, the derivative of the derivative. But we put that over dx dt also. Same denominator here and here. Up here is the first derivative of y with respect to x. The second derivative, which should be 2 here, means the derivative of the derivative. They denominator the same as one of those. Both have dx dt on the bottom. It's 541 exercise 8. X is equal to a function of t. Y is equal to a function of t. When x equals cosine t, we know dx dt is negative sine t. And from y equals radical 3 cosine t, the derivative of y with respect to t is negative radical 3 sine t. So the derivative of y with respect to x is always the derivative of y with respect to t over the derivative of x with respect to t. Meaning the top is the answer we got up there. Negative radical 3 sine t. And the bottom is dx dt, that's what we got there. And we simplify this to the number positive radical 3. So that's the answer to part A because it said find dy dx. Part B, x for the second derivative of y with respect to x the second time. So we learn this formula. It's the derivative of the derivative of y with respect to x over dx dt. Meaning it's the derivative of the answer we just got there over the same denominator that's up there. T is negative sine t. Doesn't really matter what's on the bottom in this case though, because the derivative of a constant is 0. 0 over anything is 0. So there's A and B for exercise 8. And number 10, for more practice, x is equal to a function of t. Y is equal to a function of t. In part A, before we write what part A is asking, we'll find dx dt, derivative of x with respect to t, is negative 1, t to the negative 2. The derivative of y with respect to t is 0 plus 1 over t. So part A, question is what's the derivative of y with respect to x? That would be the derivative of y with respect to t over the derivative of x with respect to t. Meaning it's this answer over here, t to the negative 1, over this answer here, negative t to the negative 2, which is positive divided by negative equals negative, t to the subtract the exponents, negative 1 minus negative 2 is 1. Negative t to the first, for the answer to part A. b, the second derivative of y with respect to x the second time. I learned this. That means the derivative of dy dx over dx dt. Meaning it's the derivative of the expansion we just got over the same denominator as this one. And the derivative of negative t is negative 1. Negative 1 over negative t is negative 2. Which can be simplified because negative divided by negative is positive. Negative t is negative 2 because t is 2 squared. So the answer is right there. Number 26. X is equal to a function of t. Y is also equal to a function of t. The question is to find the points at which the tangent lines to the curve is horizontal and vertical. So no matter what this curve looks like, the tangent line will be horizontal when the slope of the tangent line is 0. The tangent line is horizontal when its slope is 0. Slope is 0 when the derivative of y with respect to x is 0. So the derivative of y with respect to x is the same as dx dt, meaning that x equals 0 minus 3 9 dt. And dy dt, meaning y equals the derivative of y with respect to t is 0 plus 3 cosine. The line is horizontal when its slope is 0. dy dx is going to be dy dt over dx dt. And that will be 0. Any fraction is 0 when its numerator is 0. And you just need to find when dy dt is 0. And if you divide both of those by 3, you get cosine t equals 0. You can use some trigonometry. Cosine graph is black. Sine graph is red. Cosine of t is 0 every time sine t is 1. Or negative 1. What the way to do is negative. Anytime the cosine of t is 0, anytime that's true, the sine of t is 1 or negative 1. So these are the places where the derivative is 0, where dy dx is 0. dy dx will be 0 whenever this numerator is 0. And that'll be when cosine t is 0. And every time cosine t is 0, sine t is either 1 or negative 1. So x is equal to negative 2 plus 3 cosine t, which means x equals negative 2 plus 3 times 0. And y is equal to 1 plus 3 sine t. So y is equal to 1 plus 3 times either 1 or negative 1. Means y is equal to 1 plus 3, or y could equal 1 minus 3. But either way, x has to be negative 2. Negative 2 plus 3 times 0. Tangent line is horizontal when x is this number and y could be 4, or when x is this number, negative 2, y could be 1 minus 3. So those are the points on the curve where the tangent line is horizontal. Negative 2, 4, and negative 3, 2. The tangent line can be vertical because parametric curves are not always functions of x. In other words, they don't always pass the vertical line test. So a parametric curve could have tangent lines that are, look here, vertical. And vertical line is when the slope is undefined. The vertical line has slope undefined. dy dx will be undefined. dy dx is the slope of the tangent line. Will be undefined when this denominator equals 0. When dx dt is 0. What's this? dx dt is right here. Negative 3 sine t. We're going to set negative 3 sine t equal to 0 to answer part B. When is the tangent line vertical? We divide both sides by negative 3. We have sine t equals 0. And every time sine t is 0, every time sine t is 0, every time sine is 0, cosine is either 1 or negative 1. Every time sine t is 0, cosine t is either 1 or negative 1. We're looking for points on the curve. That's x and y coordinates. X equals negative 2 plus 3 cosine t. In other words, x could equal negative 2 plus 3 times either positive or negative 1. And y equals 1 plus 3 sine t. So y equals 1 plus 3 times 0. Sine t is 0. This is saying x is negative 2 plus 3, or x could equal negative 2 minus 3. Negative 2 plus 3 is 1. Y has to be 1 plus 0. So this is a point where the tangent line is vertical. Another one would be x is right here, negative 5. Y would still be 1 plus 0. Those are the points on the curve, the parametric curve, where the tangent line is vertical. One more thing about parametric curves is the length of a parametric curve. And this is just another formula to memorize. The length of a parametric curve is the integral from time 1 to time 2. These might not necessarily be times, but I'm calling that. It's the integral from a time to another time of the square root of dx dt squared plus dy dt squared with a dt out here. So let's do one or two examples. Number 28, page 542. X is a function of t, and y is a function of t. And t is between 0 and 5. We're going to find the length of the curve, the parametric curve. from t equals 0 to t equals pi. The x dt is easily 3 less than t. The y dt is 2, 3, negative 3 times t. So the x dt squared is going to be 9 cosine t squared, just like this. And the y dt squared is going to be positive 9 times the sine of t squared. And we're just going to plug everything into this formula. The length of a parametric curve is the integral from a t to another t of the square root of the x dt squared plus the y dt squared dt. So, in this case, times the t's are from 0 to pi, the t's are from 0 to pi, square root, the x dt squared is 9 squared t, the y dt squared is 9 sine squared t, the integral from 0 to pi of radical 9, radical cos squared t plus sine squared t dt. So distributing this radical 9 we get the square. If the square root of 9 is 3, it can move to the left of the middle term. And cos squared t plus sine squared t is 1, should get negative. The square root of 1 is 1, and 1 times dt is dt. So the 3, the integral of dt is just t. That's plus t, so the bracket is pi in the middle of this. So this is 3 times pi minus 3 times 0. That's the length of the parametric curve from t equals 0 to t equals pi. Let's do one more. Number 32. X equals 1 plus 8t plus 8. 8 to the 3x. And y equals t squared plus 16. And t is between 0 and 2. T is between 0 and 2. Let's find the length of the parametric curve. The length of the x dt, this is the practice time derivative. So 3x times 112, which is 3/34, times what's in the parentheses. This exponent is minus 1. We have this 1 times the derivative of what's inside the parentheses. 3/24 is 1/8. 1/8 times 8 is 8. Anyway, and it is 1. 1 times 8t plus 8 is 8t plus 8. So this exponent is a half. Sorry. 3 halves times 1 plus is 3/24. Copy this, 3t plus 8. 3 halves minus 2 halves is 1 half. 8 is there because we multiply with the derivative of what's inside here. So that's the x dt. For the formula for length of the curve, we need the x dt squared, which is going to be just 8t plus 8. So if you square the square root of 8t plus 8, you just get 8t plus 8. The y dt is 2t plus 1. So the y dt squared, using 2t plus 1 times itself, is 4t squared plus 4t plus 1. The formula for the length of a curve, a parametric curve, is the integral from a t to another t of the square root of dx dt squared plus dy dt squared. Dt out here. For this exercise, it's the integral from 0 to 2, as a given up here. Square root dx dt squared is 8t plus 8. There's a plus. Dy dt squared is here, 4t squared plus 4t plus 1. dt outside. The length of the curve is the integral from 0 to 2 of the square root of 4t squared. 8t plus 4t is 12t. 8 plus 1 is 9. And outside the radical is the dt. It just so happens that this trinomial, 4t squared plus 12t plus 9, is actually 2t plus 3 times itself. And the square root of 2t plus 3 squared is just 2t plus 3. And when you integrate the first term, the integral of 2t dt is 2t squared over 2 with a plus. The integral of 3 dt is 3t. And we're integrating this from 0 to 2. These two cancel. It's t squared plus 3t. So here where there's a t, we plug in 2. And where there's a t, we plug in 0. So m is the length of the parametric curve. T equals 0, the t equals 2.